We're working on 10.5 today, and we will start with multiplying, dividing radical expressions. So here we go. Let's just start with this. All right, the first thing we're going to do is multiply. Remember, you can only multiply what's under the radicals together, and then you can multiply what's outside the radicals together. This is actually considered a 1 times square root of 11. So the outside part is 1, the under the radical is 11. You're going to actually distribute this across each term inside the parentheses. So 1 times 5 is 5, and you can't do anything with the square root of 11. Now I'm going to take that, I'm going to multiply it by the next term. So I have 1 times a negative 1, which gives me a negative 1. Now what's under the radical? A square root of 11 times the square root of 2 is the square root of 22. Now, if you can reduce these, you must reduce them. However, the square root of 22, I can't simplify that any further. So that is your answer. Now, I really don't need to have the negative 1 in front of it, but you can write it there if you want to, but this would be considered your answer. And these are not like terms, so you cannot combine them together. All right, the next one. You have two options. You could go ahead and just multiply them together right now if you want to, or you can simplify the radical first and then distribute. It does not matter which one you do. I'm just going to go ahead and distribute it. So this is going to be 7 square roots of 54, and then 7 times a negative square root of 24. I know personally that I can simplify both of these. Now on this one, it's going to be 7 times the square root of 9 times the square root of 6. Now I know that 7 times the square root of 9 is 3, and I can't square root the 6. 7 times 3 is 21 square roots of 6. So that one is completely simplified. Now I'm going to work on the other one. I need to find a perfect square times something that gives you 24. I know that 4 times 6 is 24. So I have negative 7 times the square root of 4 is 2. I cannot square root 6. That is just under the radical. There's nothing for me to do with that. Now, what's on the outside of the radical, though, I can multiply together. 7 times 2 is a negative 7 times 2 is negative 14, and I cannot touch the square root of 6. Now, if you notice, both of these terms have a square root of 6, which means you can combine them. So 21 minus 14 gives me 17, I believe. No, not 17, 7. Plain old 7. Positive 7, square roots of 6. Okay, it's a long evening. I sometimes mess up on my adding and subtracting. Yeah, 7. All right, next one. The next one is just the multiplication. I'm going to use the distributive property for the first one, and I'll use the box method for the second one. You guys can choose which one you want to work with. So on this problem here, I'm going to take the 2. I'm going to multiply it by 1. I'm going to take this 2, and I'm going to multiply it by the square root of 5. Remember, what's on the outside of the radicals are multiplied together, and what's underneath the radicals are multiplied together. Now, this one's just a 2, and that's a square root of 5. So it's going to be a positive 2 square roots of 5. Now, I'm going to take the square root of 3, and I'm going to multiply it by 1, which gives you the square root of 3. I'm going to take the square root of 3, and I'm going to multiply it by the square root of 5, and that's going to give you the square root of 15. You multiply what's under the radicals together. Now, if you can combine like terms, you must combine like terms. If you notice on this one, you can't combine anything, you're finished. That's the answer. Now, when they were talking about the box method, this is a binomial times a binomial. So I'm going to make myself a box. And I'm going to use the first one. I'm going to put a 4 here, and I'm going to put a square root of 5 here. And it's a positive square root of 5. Now I'm going to put a 4 here, and I'm going to put a negative square root of 5 here. So basically this first parenthesis goes here and the second parenthesis goes here. Now, when you use the box method, all you're doing is you're taking this 4 times this 4, which gives you 16. You're taking this 4 and this square root of 5, and you're multiplying them together, you get 4 square roots of 5. Now you're taking this 4 and you're multiplying it by negative 5, square root of 5, which will give you a negative 4 square roots of 5. Now, the negative square root of 5 times a positive square root of 5 is a negative square root of 25. Now, here we go. So I have a 16. These two here cancel out. And then I have a negative, the square root of 25 is 5. So now 16 minus 5 is 11, and you're finished. I don't care which method you use. I personally use method A, where it's just the distributive property, but you can use the box method as well. No problem. All right, next one. Multiply the box method by using the box method. I'll do it both ways, not a big deal. This one here just means that you have 2 of them. If you want, just write it out twice. Okay. Now, when I wrote it out twice, I'm just going to distribute. The square root of 13 times the square root of 13 is the square root of 169. Square root of 13 times a negative 2 square roots of 13. And then a negative 2 times this gives you a negative 2 square roots of 13. A negative 2 times a negative 2 is a positive 4. Now remember, if they have like terms, combine them. The 2 terms in the middle are like terms. The square root of 169 is 13. This gives you a negative 4 square roots of 13. And then you have that positive 4 on the end. You combine like terms, what you can combine. So 13 plus 4 is 17 minus 4 square roots of 13. Now, once again, if you want to use the box method, you're more than welcome to use the box method. So here is the box method. Whoops. Trying to make it look even. All right, so what I'm going to do is this. I have the square root of 13 minus 2 here, square root of 13 minus 2 here, because you have 2 of them. So the square root of 13 times the square root of 13 is the square root of 169, which is 13. Negative 2 times the square root of 13 is negative 2 square roots of 13. Negative 2 times 13, square root of 13 is negative 2 square roots of 13. Negative 2 times negative 2 is 4. So you add these two together and you add these two together. So that gives you 17 minus 4 square roots of 13. If you notice, you get the exact same answer. Now, if you want to be wild and actually use the formula of a perfect square trinomial, you could do that. So this is a square. A plus B squared is equal to A squared plus 2AB plus B squared. If you want to be wild, you can do this. And then here's another formula. You learned this in Algebra 2 way back in the day. It's been a while since you did this. That's A squared minus 2AB plus B squared. So this is what you would do. You take the first term and you square it. So that gives you 13. You take this term times a negative 2, and then you multiply it by 2. So that gives you a negative 2 square roots of 13. You multiply it by 2, and it gives you a negative 4 square roots of 13. Then you square the last term, which is negative 2 times negative 2 is a positive 4. Combine like terms, you get 17 minus 4 square roots of 13. That is 3 ways to do one problem. Your choice, do what you like. All right, next one. Next one is multiplying using the box method if you choose to. I am going to use the distributive property because I just think it's easier. So here we go. So that's going to give you 16. This here is going to give you a negative 4 cube root of 7. This here is going to give you a positive 4 cube root of 7. And then this here is going to give you a negative cube root of 49. So if you notice, the two middle terms cancel out and you're left with 16 minus the cube root of 49, and you cannot reduce the cube root of 49. Now the next ones, they say that r has to be greater than or equal to 0, and so does s. Otherwise, you'd have a imaginary number underneath the radical if it's negative. So in this case, we're just multiplying. So the square root of r times the square root of r is the square root of r squared. And the square root of r squared is r. Done. The square root of r times a negative square root of s is going to be a negative square root of rs. Now, I'm going to take this s here. I'm going to multiply the square root of s times a positive square root of r, which is going to give me a positive square root of rs. Then I'm going to take the square root of s, I'm going to multiply it by a negative square root of s. It's going to give me a negative square root of s squared, which is just a negative s. Okay, remember the s is the negatives in front of the s. Now the two middle terms cancel out and I'm left with r minus s, and you're finished. That's it on that one. All right. This is considered rationalizing the denominators. You're never allowed to have a radical in the denominator. So if you are, you got to get rid of it. So on letter A, in order to get rid of the square root of 11, I'm going to multiply the top and bottom by the square root of 11. The square root of 11 times the square root of 11 is the square root of 121. The square root of 121 is 11. And then the numerator would be 5 square roots of 11. Nothing else you can do with that. Now in the denominator, I got a square root of 5 in the denominator. I can't have that. So I'm going to multiply it by the square root of 5. You're just going to multiply it by itself. And I'm going to multiply the top by the square root of 5. Whatever you do to the bottom, you must do to the top. Now, the square root of 5 times the square root of 5 is the square root of 25. The square root of 25 is 5. So 5 goes here. Now the numerator, I'm left with 5 square roots of, the square root of 6 times the square root of 5 is the square root of 30. And you're finished. No, you're not. If there's a number on the outside, like here was 5 and 11, you can't simplify that. But this one has a 5 and a 5. 5 divided by 5 is 1. So I can cancel all of that, and your answer is going to be the square root of 30.